Infrastructure estimation is a really complex topic. How do you correctly size infrastructure for software products? How do you correctly size your servers? How do you size your databases? Which memory do you put? How much compute do you want? It's a very there's usually no scientific way to calculate it. That's what we'll talk about in this video. So let's start with a sample problem. Let's take a simple mobile application where you have, let's say a few thousands of users concurrently logged in, and there's a web server, there's a load balancer, and then there's an application server, there's database, right? This is a very simple design, but it will help us understand what are the things that we need to worry about and what are the things that need sizing and how do you go about it. We'll talk on further. So the first thing to understand is when you are building any app, when you are building RESTful APIs, or when you are building service-based architecture, the payload of the traffic is very important. How big is your payload? That has to be determined, because usually people talk about number of users but ignore the payload size. Number of users is very important. Number of concurrent users is equally important, but the payload size is something you should pay very close attention to. Why? It's because a lot of times payload is usually expected to be small, but we ignore the images that we send along with the traffic. If you think about it, a text could be a couple of bytes and the payload would be substantial, right? It would be close to a couple of bytes, maybe in 800 bytes, 600 bytes and so on. But if you add images and add in an assumption that an image is usually 500 bytes, you're making it more than a KB. 500 KBs, you are making it in the range of hundreds of KBs. Now, as you add in more images, because most websites these days are content heavy, there's always images exchanged of different sizes, there's always graphics exchanged, SVGs exchanged, and so on and so forth. So you should pay very close attention to them and size that payload correctly. Get a ballpark number, not too high, not too low, something that can keep you comfortable, and then use that as a multiplication factor along with your number of users. Now, usually people try to balance between number of concurrent users and number of users, and you can again go for a spot which is, let's say, closer to the concurrent users, because that's what really matters. But to support the scaling needs, you should pump it up a bit. So if this is concurrent on the left hand side and on right hand side is the actual number of users, let's say daily active users and concurrent users, you should probably have a concurrent users pump it up by 25% and you should have a good number. Use that and the multiplication factor along with your payload size to calculate how much bytes or kilobytes do you need, right? And that's pretty much the data that you need to keep in memory. Please think about that. This is the minimum volume that needs to be stored in the whatever is going to receive it. Now, it could be a queue, it could be an application server, it could be a pass-through load balancer. So if an assumption is network load balancers do not add a lot of latency to it, so you can very safely ignore them. But for high traffic applications, you might have to optimize network load balancers as well. So when you pass through a load balancer, you then end up on your app server, your server basically, and the memory on your server is pretty much the per second volume that you're transacting plus the amount of memory framework requires. So you can use this method to calculate the amount of GBs you need. You should not target for 100% utilization, and not either don't go for like 20% utilization, because that would be wastage of money. Go for somewhere in the range of 60% and you should be very safe. Watch out the previous video that I've talked about non-functionals, and that can help you define these numbers much better. So now that we have an application server where you have landed your data and you know the amount of memory you need, the second question is usually the compute. As a thumb rule, you usually start small. 2 core, 4 core, 6 core, 8 core are very, very standard when sizing normal service type applications. When you are in a containerized environment, you might even go 0.5 cores, but that's not really recommended. So So try and understand the type of computation you're doing, right? If your computation is passed through, if you're taking the call and passing it to database and giving and return back, then you don't need a lot of compute. But if you are doing a lot of business processing, if your API calls have internal 5 different calls and your data has to be kept in buffer, if you're joining a lot of data using ORMs, then you need additional memory and compute. So do factor for them. So this is another parameter which you should write down and measure by load testing or by regular testing as to how much you are consuming. So once you are done with CPU and compute, half the battle is won. Right? When you have a good understanding of your CPU and compute, and this is the bare minimum you need, then you can define a vertical scalability factor and horizontal scalability factor. You can say that for vertical scaling, I might just want to go twice my minimum requirement, so that in a good day I clock half of it and in a bad day I go 70-80%. But at the same time, you don't want to take a tier which is very big, because you might never cross that 80% threshold and then you're wasting 20%. So a good strategy in this case would be to go for horizontal scaling and multiply the number of servers you have. So using this, you can very nicely size out an infrastructure. Assumptions, I will repeat, you should pay very close attention to your payload size. What is the type of data? Is it Unicode? Is it ASCII? ASCII takes 1 byte, Unicode is 2 byte. Images, 300 kbs. What else are you sending? Are you encoding a lot of data like documents in your, probably base 64? Not a good idea to do, right? You might want to use an S3 bucket and pass the URL for a prefetch or a post-fetch operation. So think about these kind of things and then decide on the first assumption could be how much is the payload size. The second was, the number of concurrent users, and then you go about multiplying that to get a good understanding on the memory and memory of it. And then you move forward to understanding the type of operation you have. For each type of operation, compute needs are different. You'll have to test it out to figure it out. So there you have memory and compute, and then you can do a horizontal and vertical scaling, which should be a very, very good conversation to have. Moving forward, databases are different. Databases don't get added volume every single day, but volume and storage is not the only thing you need to worry about. Important factor to remember in cloud, database products are charged by the amount of storage that they have, and that's actually really cheap. What is actually costlier is the amount of query that you write on it. So when you write a query and a query takes a longer amount of time, you're getting billed for a longer duration. Please keep this in mind. So for database, it's not just the storage, it's not just the percentage growth. It's also the tier of server which is used behind the scenes for the database. And different vendors have different ways of pricing it. Some vendors will, allow you to install it on a traditional server where they'll give you, a very transparent memory and compute and say, hey, come and install on an EC2 and take a Postgres, things like that. Managed databases might come in a very different flavor. Snowflake is very different. Databricks is very different. For example, they might say, I want to take one Databricks compute unit, which is not the same as, which is loosely a combination of the underlying infrastructures, memory and compute, which is very, very hard to determine unless and until you test it out. So for databases, and I purposely used Databricks as also a database because there's some people who are using that, right? They really need a very fast in-memory database. So Databricks and Spark is a good candidate there. So that's what I'll say is how you should go about databases. Now, once you have databases and compute, I would say 70% of the battle is won. Then what you need to size are your number of load balancers, and then there's tons of different parameters that can be talked about. In the next video, I'm going to take a look at Azure pricing calculator and we'll see how to size infrastructure using a pricing calculator so that we get to a more accurate number rather than speculative and assumptions. Know that this what we just did is called back of the envelope or back of the hand estimation. This is just a process to give an understanding of where things are headed and not for really cost calculations. Alright? Do watch the previous video on non-functional requirement. That's a prerequisite for understanding estimation. Thank you for your time. Subscribe to Cafe IO. Bye bye.